Knowing that temperature varies in different locations around our planet, it's going to be pretty important for us to create a map. And in this map, we not only want to show where the continents are, but whether these places are going to be warm or cold based on their latitude and the amount of sunlight they receive. This map is just showing us a really generic example of a temperature map. With these, we're going to use different colors to represent different temperatures. And it's not important to know the exact numerical temperature, but we're going to use cooler colors to represent colder temperatures. So things like purple and blue is telling us that it's cold temperature, and our warm colors like orange and red is going to tell us these are the warmest temperatures or the hottest areas. So when we look at our map, we'll notice that around the equator is where these red areas are, which makes sense because we know that around the equator we have the hottest atmosphere. And then as we move towards our poles, they're turning into blues and purples, which is telling us that it's getting significantly colder. So here, the color just represents the temperature. Cool colors represent cool temperatures, whereas warm colors represent warm temperatures. With these world maps, we can figure out some global patterns and how temperature changes worldwide. So like we noticed on the last slide, we generally see that starting off from the equator around our tropics, and we start increasing our latitude, we're going to start decreasing our temperature. Higher latitudes like our poles are colder than lower latitudes like our equator. But when we're looking at the isotherms, again lines showing us equal temperature in different areas, we're going to see that they're going to shift with our seasons. Because we're going to have different hemispheres tilted towards or away from the sun in different seasons, we'll see that in the summer months, our warmest isotherms are going to shift towards the northern hemisphere. And then during the winter, we're going to see that it's going to shift to the southern hemisphere. But we can also see some major differences between land and oceans. We'll notice that our lands are always warmer than the surrounding oceans. And all of this goes back to the specific heat of water. It's always going to be easier to heat up a continent than it is to heat up an ocean. Another thing you might notice on these temperature maps is the difference in the isotherms between the northern and the southern hemisphere. In the northern hemisphere, they're pretty swirly, whereas in the southern hemisphere, they're pretty much straight, or at least a lot straighter than the northern hemisphere isotherms are. So the reason why the isotherms look straighter in the southern hemisphere and are more stable and don't change as much is due to the fact that the southern hemisphere is mostly water. Because it takes a lot of time and energy to heat up or cool water, it doesn't change a lot in the southern hemisphere. The northern hemisphere, though, because it's mostly continents, is going to heat up and cool down quickly throughout the year. So we'll see that our isotherms change a lot more in our northern hemisphere because of this. But if we could lay a map showing the direction of our ocean currents and their locations, they will be in the exact same locations of the isotherms on this map. And this will become important once we go over our ocean currents chapter. But worldwide, we can also see differences in the annual temperature range. And the annual temperature range is how cold does it get in the winter versus how warm does it get in the summer. Around the equator, the temperature doesn't change that much year-round. We might only have a 2-degree difference between winter and summer. But as we start increasing our latitude towards the poles, we're going to have a greater difference between summer and winter temperatures. Now it might be negative 40 degrees in the winter, whereas it's 60 degrees in the summer. It's a lot more than that 2-degree difference at the equator. And because of the specific heat of water, we see that the annual temperature range is the greatest over our continents instead of over our oceans.